This exercise is going to have us do the most basic thing, one of the most basic thing we can do with the fork system call, that is to spawn a number n of direct children. So let me start by moving directly to the middle of this description here and to this diagram. Okay, this is what we want. This is the final result we want. We are going to write a program which we are going to run, and this parent process is going to generate 3 different children. All those children are direct child from the parent process. They are siblings with one another. Okay, so the detail of how we are going to do that and what we are supposed to do exactly are written here. Pretty much we want the parent process to be able to display some information when it is forking those children, and the children process to display also some information as they come to existence. So you see here an expected output trace. Okay, so this is running the program here, running the executable. The parent process will use this convention for many of the exercise that we are going to do on the fork system call. Every time you want to display some output from one of the process, you better find a way to clearly state on the screen which process is displaying which line. Otherwise it can get really weird. Okay, it can get really difficult to follow up which process is printing what, especially that, as you know by now, with the scheduling doing its job in the background, you cannot be sure that once the parent fork, for example here you see that the parent is displaying a message saying I am spawning child number 1. Well, as you can see here, the scheduler tricked us, because by the time the parent is displaying this message on the screen, the child number 1 has been already started, has been already displaying his own message on the screen, and is already sleeping, waiting for the parent to do something with it. So you see, you cannot expect that the parent, because it's forking a child, is going to have priority displaying, hey, I just forked a child, and then the child only is going to work. This is something that's really important to understand. So for that reason, each line is preceded here by a little message and a tabulation. The message is between square bracket parent or child followed by the number of the child. Okay, so we start the parent process. We are going to display our own PID just to help us track that everything is working fine. Then we are going to ask a number n from the user. This is a number of children we need to generate. In this example, number of children is 3. We are going to enter a loop and we are going to fork 3 times. Okay, each of the child is going to do the same thing. Hello world, my PID is, and we are going to use a get PID function system call here to display our PID, and my PPID is same thing, we use get PPID. So we'll have to make sure that the PPID of the children is actually the PID of the parent. If something is different there, well, we have a problem. Then the child is going to say sleep for 3 seconds, okay, and then terminate. The parent is going to announce every time it has spawned a child, and we are going to display its PID. Why? Well, just because we can, first, and second, because that's going to help us once again verify, that our program is working fine. When we do things a little bit more complicated with the fork system call, that would be really important to take a piece of paper and to trace on paper, this is PID 1085, has been generating child process 1086, may verify that 1086 is really a child of 1085, etc., and draw a little diagram on paper. For this exercise, things are relatively simple, so we won't have to do intensive debugging. Child number 2 is going to do the same job. Okay, hello world, this is me, and this is where I come from. Okay, verify this is the parent PID. Sleeping for 3 seconds. Child number, where is it? 3 is going to be here. New PID. PID of the parent is a PPID. Everything works fine. And every time the parent is displaying, I'm spawning child number 1, child number 2, child number 3. And then when the children are done sleeping for 3 seconds, they display on the screen simply child 1 done, child 2 done, child 3 done. You will notice that after the child 1 is done, the parent display on the screen, I'll terminate when you press enter. We're going to use just getchar, okay, 2 getchar in a row to make pretty much our parent process wait for us to hit enter before to terminate. So that will give a chance to the child processes to terminate, okay. And of course, as you can see here, well, that means we are going to have zombie somewhere, but we are going to get into that in the next video, okay? Right now, we are just going to get our first version of the program working. When the user presses enter here, the parent process will terminate. Okay, so let's move on to implementing actually this. In your Conqueror window, you're going to create a file a01.c. I have it already open, so let me go and fetch it. And we are going to implement the code to fulfill the requirement that we just went over. So what do we need to include first? Well, #include stdlib.h, #include stdio.h, stdlib for just being able to do an exit success or exit failure. I mean, if only that would be like why we need to include it. stdio for all of our IO, printf, scanf, etc. get char. Include uni std.h for some of the constant that we are going to use here, such as the PID_T data type. Okay, what do we need? Reading the exercise in more detail, you will see that at some point I ask you to use actually a child function. This child function will take as parameter a number n, which is a number of the child this function is running inside, and it's going to represent the code executed by each of the 3 children. It's really a good idea actually to isolate the code of your child process into function. Okay, that makes your code a lot easier to debug, as you are going to see even on that simple example. When we invoke this function from the main, we'll pass as value n the number of the child. Okay, so if I ask to create 3 child, those three children, will have numbers 1 to 3. Okay, let's go inside of our main. This is boilerplate code here. And I'm going to put here, even for adopt, we're going to reach it and exit success to notify that when we reach the end of our main, everything went okay. I exit normally. What am I going to need? Well, I'm going to need a variable, let's call it n, to respect what was in the specification of the exercise, where I'm going to store the number of processes the user wants me to create. So let's start by asking from the user, please enter a value for n. And I'm going to let the user type something here, so I'm going to use scanf. Scanf, I want to read an integer. I want to store it inside of n. Okay, this is code that you are familiar with. One thing that I had also in the exercise, before even to ask for a value of n, I had a little printf here that just said, this is a parent process talking, followed by starting. My PID is, and I'm going to display the PID number. How do I obtain the PID? Well, this is one of the first system call that we studied, okay, get PID. So whatever process will run this code will obtain its PID, display it, and we are talking about the parent process here, so everything is fine. Okay, so I read a number n, and then what do I need to do with it? Well, I'm going to do incremental, okay? So there's no need really to do that in this class. By now, you guys have more experience programming, etc. But I would like to recommend you to tackle your problems little step by little step. For example, here, I just want to make sure, you know, that everything is working right now. I'm a little rusty. I didn't, program in C for a while. So I just want to make my program little piece by little piece. I just read %d. So I'm adding a piece of code here, just one line that is going to display what I just read. Why? I just want to make sure that my code works so far. So that's the only thing I can test. So I save. I'm going to go back to Conqueror, and I'm going to test just that, so that I'm going to eliminate every syntactical error that is in the code here before to move to the next step. For example, exit success, there's a S missing. That's not a big deal, okay? But I'm constructing my code little chunk by little chunk, so that once I'm done making sure that this works, this is syntactically and semantically correct, then I can move to add another feature. And if there is a problem, I know this is a new feature which is responsible for the problem. So there we go. Let me go back to Conqueror. Fix that little syntactical glitch. Looks like we are good now. I'm going to run this program just to see what it does. The display of the PID seems okay. I enter value 3. I just read 3. Okay, we're good. We're making progress. So I'm not going to do formal testing of this code, but this is the ID behind it. Okay, I know that up to here I am Good. I can now work on the next step, the next feature. Well, the next feature is really what I'm writing this program for. I need to fork free child process. So refer back to the reading assignment, okay, to the lecturing material. The deal is that this is boilerplate code, okay? I can make a loop for I equal 1, I lesser equal to n I plus plus. And if I need to create free children, I will iterate 3 times in this loop with I value 1 to 3. So that sounds good as a start, okay? I'm going to have to call fork at some time. So let me not do it sloppy as I used to, but let me do it clean. I declare a variable f of type PID underscore t. Okay, I could use an int here, but it's better to use the exact same type that's going to be portable. So I have a variable f in which I'm going to store the return value of calling the system call fork. Well, this return value is going to be a PID t. Okay, the convention is that if f is lesser than 0, I got an issue. Okay, if f is lesser than 0, that means, well, I cannot fork for one reason or the other. For example, another student has a fork in an infinite loop, and this prevents me from being able to fork on the system I'm using. Okay, well, if that happens, yeah, you cannot do much about that. So what we do, we handle the error in a very crude way, okay? We exit the program after displaying a little message with p error, and that's it. 3 cases to handle every time you call fork. First case is there was an error. Second case is f equal 0. What does that mean for the return value of fork to be equal to 0? Well, that means simply that if fork returns 0, we are right now executing the child process. Easy way to remember that is that, well, if you create a child, if you are in the parent, fork will return to you a handle on that child, the child PID. If you are inside the child, you don't have a handle on any descendant, so you just return 0. We have a function here that's supposed to embed everything we want the child to do. So I'm going to call it, and I'm going to call it with I, which is the number of the child I'm creating right now. Okay, there are different design considerations here to take into account. Do you want this function to do everything for the child? Okay, so pretty much I don't want to ever return from it inside the child. I want this child function to be my main for each of the children. Or do I want to call this function, then return, and then do something else? Well, depending on what you want to do here, I would suggest that if you do not want to return ever from that function, you put, just for sake of safety, an exit here. Okay, because if you intend to never return out of this child function for the child process, if you intend your entire child process life to be executing only that code, if something happened here, you break out of the function, you return out of it, or you forgot simply to exit, you are going to make a mess, because you are going to return from child I. Once you're done executing that, you get out of the if, you come here at the end of the loop, you go back at the beginning of your loop, and guess what? Your child process is going to execute a fork. Do we intend our child process to ever go back to this code and execute a fork? Certainly not. Therefore, we make sure, even if it's a little redundant, because I'm going to put an exit in the child function as well, we make sure that we are never going to be able to get out of this execution path as the child process. And then I'm going to put the if statement, but really I don't need it. Okay, if f is not lesser than 0, if s is equal to 0, then f is greater than 0. And I'm going to here have the code that will be executed by the parent. So it's not a bad idea to add a little command here. This is a parent part, okay? This is a child part. That's not going to hurt anyone to write clear code. Okay, so in the parent part, what do I have to do? Well, you saw that in the description of the exercise, we need to display some message to let the user know what we are doing. So parent, spawning child number, let's say %d, and also the PID is %d. So I want to say I'm spawning child 1, let's say, and the PID of the child 1 is x. So what is my number of child? Variable I. Where do I get the PID of the child that I just created? Variable f, the return value from fork. I'm going to add a little sleep for 1 second, okay? Block my parent process for 1 second before to move to the next instruction. I do that a lot in those exercises so that things do not go too fast. That give us a pace, okay? So we can look at the execution of the program, and the parent doesn't go too fast. It lets time to the child to be created, etc. So if you don't put those little sleep here and there, you are going to have something that's just going to go like vroom, like, you know, your parents create 3 children, they terminate immediately, and this is annoying when you're trying to witness things such as, for example, the creation of zombie processes or things like that, okay? So this is, of course, not efficient. It's just for us to be able to observe better what's going on in the parent. Okay, well, we're going to do that 3 times. Okay, 3 times we're going to call fork, 3 times we're going to come here and say, hey, I'm the parent, I'm sleeping, and I'm creating another process, and 3 times the child process is going to execute this part of the code only and never go back to the loop to create children of its own. What else do I have to do? Well, the last part for the parent is display. Once we are done creating all those child process, display on the screen, I'll terminate when you press enter, for example, or any other similar message, okay? And we are going to have to do a get char to read a character from the screen. Okay, little problem here. Those of you who took COP3515 with me are already familiar with that kind of trick in the C language. If I do get char only once, it's going to look like this get char is being ignored for no good reason. What happens? I read here an integer, but when you type your integer, you type 3, enter. What happened to the character enter? It's not read by scanf because scanf reads only a %d. So when I come here and I call getChar to just read enter, guess what? There was already an enter in the keyboard buffer. I'm going to just read that enter and move on. So I need to call it twice. So what I'm going to do instead, I'm going to call getChar here, and actually I don't even need to take into consideration the return value, which is a character being read. I'm going to read getChar right after scanf to absorb this enter that is typed after the number, and then I'm going to use again getChar here to just this time wait for the user to press enter. And after that I should be done for the parent part. So I'm going to save, and I want to test this. So to test it very easily, I need to find a very simple task for the child to do. Well, in the case of this exercise, the task for the child to do is anyway simple. So before to test, let's go ahead and code the child as well. This is not going to add much difficulty. What do we need to display as a child? Well, our banner message is child number D. Okay, so I'm going to here display the number of the child. Then what do I need to display after that? Hello world. So I'm just following the specification here. I want to display hello world. My PID is %d. My PPID is %d. So after that, I need to get my PID. I need to get my PPID. After that, what do I need to display as the child? Printf child, always this banner. Okay, this is my ID. This is process child, process number X talking, sleeping for 3 seconds. The number of the child is still n. Sleep for 3 seconds, and then once I'm done with that, well, I'm pretty much done. So child %d, always the same trick here. I'm done. \n, the number of the child is n, and then I will exit with exit success. Like I said sooner, as long as I make sure that this here terminate every execution path in the child function, I don't need to put it here, okay? But I'm just trying to give you little tricks here that you can apply to make sure that your code is most likely correct, you know, and you catch things such as forgetting, for example, to exit from a specific execution path in your child function. Okay, well, at this point the basic IDs are there. Okay, so we need to debug. We need to first start by making sure that the syntax is okay. So GCC a01.c. Okay, syntax is alright. It's always good news, doesn't mean that our program is working. Let's test our program now, and I'm going to make this window a little bigger here. So I'm running my program right now, parent blah blah, so 3631 is the parent ID. Please enter a value for n, 3. Hello world, things are going to scroll on the screen, so let's try to keep in touch with them, okay? If you ever have here a bunch of messages that scroll, etc., you are pretty much creating children after children after children after children, etc., and it doesn't seem to stop. Let me open a little parenthesis here. What do you do? Well, first you do Control-C to terminate your main program, okay, your main process, and then you type kill all a.out. Okay, assuming that your executable name was a.out, all your processes are going to have this name because they derive from a.out. Kill all the a.out is going to allow you to kill all the process a.out that are being crumpling over the system. Make sure you do that relatively fast, okay? As soon as you see things scrolling beyond 3 children, yeah, you are probably in an infinite loop. So Control-C to stop your program, kill all space a.out, enter, so before the system actually goes down because of a fork bomb. Okay, so back to what we had here. I kind of interrupted the demonstration here. Let me redo it. I want 3 children. We can see here the child 1 is awake. Well, there is a little problem here. I forgot to backslash n at the end of the display. It's alive. Okay, it comes from the right parent. It sleeps for 3 seconds. Parent tells us, I spawned child 1. Child 2 has been spawned as well. Comes from the right parent. Child 3 has been spawned as well. Comes from the right parent. And then the children one by one are done. Meanwhile, the parent is still waiting for us to press enter. Okay, I press enter now. The parent terminate. So I'm going to put back the code again, and we are pretty much done with this first part of this exercise.